morning, this is Eric Miscoll with EMSNOW. I'm here again at IPC Apex in San Diego. Stopped by the Henkel booth, ran into Mark here, and Mark just wanted to spend a little time, hear a little more about what Henkel's doing and what's going on. It was interesting, we were speaking about this, and you were kind of alluding to kind of almost an inflection point, a change is going on within solder delivery. Can you speak a little to that, please?
Oh, good morning, Eric. Yes, I've seen this around the past few days in the show and also in the past 6 months. One of the drivers in the industry is how can I improve my process, and process control is the real drivers with sustainability. So the question would be is there a technology out there that drives you to that deliverable? So typically at the moment we use stencil printing for all the paste deposition process onto a circuit board. But one of the challenges we have is how to improve our yield, how to improve our capacity without actually spending extra money when we don't have to do it. So people in the industry have been looking for alternate solutions. One of the key drivers is that process control, and paste printing doesn't give that control. So now they're looking for something else, and that new technology inflection is solder jetting. So solder jetting is a different process. It has a process very, let's say, capable of putting deposits down in a fine deposition area with very high tolerances. But the speed is the big challenge people are concerned by, because printing, you can have a circuit board that has 3,000, 10,000 IOs. How can you compete with a jetting machine to get the same deliverables in the same time frame? So the industry has been asking, well, you're doing a technology inflection, but do you have the ability to do mass production without slowing down the mass production line? So one of the key drivers at the moment is, well, how can I optimize my production line by utilizing both technologies together? Because ultimately what I'm trying to drive towards is first time pass, high yield, making sure I have no rework, and my cost of my products becomes a unit cost and doesn't have the cost of the rework accountability. So for printing, we can get very good statistical control, but with jetting, we even get higher statistical control. So we're going from a 1.66 target CPK to a 2 and a 3, but with a tolerance tightening. So going from a tolerance tightening of plus or minus 50 to plus or minus 20, 25. The rate of deposition, let's just say it's 3 million depositions per hour for a printed board to 1 million for a jetting capability. So you are getting into the realms of technology that can be embraced and not just looked at.
Now, is this causing confusion then with customers?
That's a very good question as well, because one of the things we have seen is that people are not aware of the technology and what it can do. When people bring out new products into markets, you have technology inflections, you have economic inflections, people are very skeptical for change. Why are they skeptical for change? Because they don't be first to implement. When you see somebody implement that change, they believe in it. So one of the drivers at the moment is you'll see a lot of awards coming out on technology, making people aware that this is something new, but believe in it because it's delivering. And that's one of the key drivers, how to make that the market aware of it and show the benefits of it at the same time.
Now, does it require anything, different material capabilities or within that in order to be jetted rather than printed?
Well, the rheological properties are slightly different because it's more of a product that's flowing through a small orifice as opposed to being printed and rolled across a stencil. So the rheological properties are different, which means the chemistry is slightly different. Now, the key driver is for printing is homogeneity of the solder paste. It's a dense suspension. The powder has to be suspended by the flux. Moving that from a printing paste to a jetting paste, same concept. The paste has to be a homogeneous mixture. The powder has to be suspended by the flux. If it's suspended by the flux, it'll jet out in the appropriate volume control. If it doesn't stay in homogeneous process control, separation happens, and then the process falls off. And then if you're talking about how skeptical people are, that's a skepticism. They believe it can't be delivered consistently over time. And that's the big drivers in the industry, is how can you convince the industry that I have a new technology that's going to be better than what you have, and you can use it.
And which begs the question, so what benefits are your customers going to realize from this process?
So when you use this material going forward, one of the drivers is how can I put the product down with accurate deposition volume deposits? That's what you normally use for printing. For jetting, it's the width of that deposit, because you have an ejector head which controls the volume. But what happens during reflow is that paste pulls back onto the metallization area. So you can overprint by a little, but it'll pull back. And that's the one of the key drivers to be aware of, is that you can overjet that small area deposit, we will pull back. So you can go down to the 120 micron pad openings, all the way up to the 700, 800, 900 with the same aperture area. Just every time, and still get the good coalescence post-reflow. And the key thing is here, when you have those small deposits and the flux is homogeneous with the powder, you still will get that attribute of being able to reflow in air. If you can reflow in air, back to the sustainability metric that everybody's looking for, what is my cost of ownership? I do not want to spend money when I don't need to spend money, and nitrogen is one of those key things. So reflowing in air on small powders is the good advantage. Now the other thing about it is you don't have to over-engineer your printing solution. So you have a test board now, you have large components and small components, and what do you do typically for a design? You take the smallest powder size to do the board build. Now there's no need to do that. You can do your general one, and you may have only 5% of the board need injecting solution. So now you're building control on a high-density interconnect control problem.
This is excellent. This is excellent. Thank you for sharing that. And I got to say, on a personal note too, I'm so glad they brought you out of the labs and brought you out front here, because you have a unique ability to kind of communicate this to the audience. So thank you for your time, and I appreciate it very much. Thank you.